These notes are on hashing, hashing functions, hashing tables. So imagine you have a website where customers can order food from a restaurant that you run. You might store the food name in an array and the price as a second element of the array. So here we have a burger for 25 cents. And I'm going to copy this. And we're going to put all of our food pairs for the restaurant in one larger array. So we have these pairs, which are subarrays. Well, they're not subarrays. They're just arrays with a length of 2. We'll do fries, and these will be 20 cents, and so on and so forth. All the food in the restaurant. If we were to search through, let's say the customer wants fries, and we need to send them the cost of fries, then it will need, the simplest way to get them that cost is to cycle through this array, and for each food item cost pair, it would take O of n time. And if we ordered it with some sorting algorithm, then it would take O of log n time. But we can get much faster than this. So with hashing, we can get it to constant time. In the best case scenario, we can get it to constant time. So to understand hashing and why it brings the complexity of this search down so much, we first need to understand hash functions. Hash functions have one input and one output. So as a kid, you might remember creating secret codes. Say A equals 1, or corresponds to 1, B corresponds to 2, C corresponds to 3. And then you would write words as they are represented in a numeric string. So 1, 2, 3 corresponds to ABC, or ABC corresponds to 1, 2, 3. This can be viewed from the paradigm of a hash. So where ABC is our input to the hash function, and 1, 2, 3 is an output to our hash function. And this works as a hash function because there's one input to one output. And actually, this is incorrect. A given input has one output. So in this particular hash function, where each letter is given a number, it followed the rule of one input to one output, which I believe is a bijunction. But a hash function, let me just reword this real quick. Have one output for any given input. A hash function can be and should be, there should be fewer outputs for a larger number of inputs. So for example, instead of converting our letters to a string of numbers, we can add the numbers. And then 1, 2, 3 just becomes 6. So, or ABC becomes 6. Or we can take the product of the numbers, and ABC would also be 6. But notice that CAB, because of the transitive property, also corresponds to 6. So this still is considered a hash function, taking the product of all these values, simply because these are two given inputs, and those given inputs correspond to the same output, respective of basically the function is completely consistent. You'll never give it the same. The only thing that would make this not a hash function is if ABC sometimes referred to like 5, which it never does. So, all right, now a practical example. Imagine you have another website where you're trying to give the customer or the user of the website the most common synonym for any word in the English language. So bad would correspond to evil. So if I log onto the website and I search bad, it'll just spit out evil immediately, and as fast as we could possibly get it. So we're really going to need to optimize this search here. Optimize it beyond what we did up here. We want to optimize this to constant time. We want to work for any word. It should give us a synonym very, very quickly. So to use that, we take a concept called the hash table and we pair it with a hash function. So a hash table contains a list of cells, and we'll say these cells are 1 to 9, and each cell can contain one or more pairs, and the pairs can be any values, but in this case it will be strings in the English language. So to determine what pair will correspond to which cell, we will use a hash function, and the output of the hash function will correspond to one of the cells on the hash table. And this allows us to quickly narrow down where a word's synonym is, or in general terms, it allows us to narrow down where the value corresponding to a key is in a hash function, where, say, bad would be the key and evil would be the value. The key is the input to the hash function, and evil is the value coming out of that hash function as an output. So if we use that product example where we took the product of all the values of the alphabet that a given string contains, bad corresponds to 1 times 2, and then D would be 4, which is 8. So we would have our pair here, bad, evil. So initially, when someone searches a synonym, it would do a long search through an extensive list, sorted or unsorted, of the English language. But once one request was given, then subsequent requests would be much, much faster because of the hash table. So our customer searched bad. It searched through a long list, used probably O of n or O of log n time, and it gave us this pair. And now we throw it into our hash table using the hash function. And its position, remember, corresponds to its position or cell corresponds to the output of that hash function. So the next time somebody searches for bad, then it will just take the product, and instead of searching for the synonym in our initial list or initial slower table, unsorted table, it will just take the product of bad and say, oh, it's in cell 8. And then it will go to cell 8 and search through all the pairs in cell 8, which if we got bad twice in a row would just be O of 1 time. So that's how you reduce it to O of 1 time. And let's just give another example. Let me come up with one. Cab corresponds to cell 3 times 1 times 2, which is 6. Cab's closest synonym is taxi. So say a second or third customer searches cab, and we get cab taxi is a pair in cell 2 of the hash table. So we have cab taxi. All right, and this would also take O of n time the next time we needed to come up with a synonym. So Sorry, not O of n, O of 1. It would take constant time. O of n is not constant. It depends on the input to the algorithm. All right. Now this has a caveat. Hash tables have a huge caveat, which is if the key to a hash function is used twice in the hash table, so instead of bad, we had dab, then it's going to share the product because of the transitive property of multiplication, just like with ABC and CAB, these shared a value. These two keys, ABC and CAB, when inputted into our hash function, share a value of 6 because of the transitive property of multiplication. So does bad correspond with dab. So say a fourth customer searches for dab and the synonym is pat, then this would also be placed in cell 8. And that would take, now anytime someone gives the hash table or initial word, anytime someone requests a synonym for a word where that word has the same product as bad or dab, then it will take O of n time, where n is the number of pairs in cell 8. And that does slow it down. So you have to sort of balance having justifying using a hash table and then also not putting too many words in one cell. So a hash function should really equally distribute the values for an arbitrary key. And that is all I can remember about hash tables off the top of my head.